Greetings, everyone. We're delighted to have you join our webinar series. Today, our senior instructor, John Waggoner, will enlighten us on the recent updates in NFPA 70E. Without any delay, I'll now pass the virtual floor to Mr. Waggoner and commence our webinar.
Welcome to the Infrared Training Center and this webinar on NFPA 70E 2024, the new electrical safe work standard that was released last month. We're going to take a quick look at this standard and some of the new things or modified items that impact infrared thermographers. My name's John Waggoner. I am a senior instructor for the Infrared Training Center in Hudson, New Hampshire. I have spent over 35 years in the electrical testing, maintenance, and troubleshooting side of the business. In those 35 years, I've spent 31 years using infrared cameras. I've performed infrared thermography, managed infrared thermographers, and also taught infrared thermography. I've also spent 2 decades working with the NFPA 70E electrical safe work standard as well as OSHA. What we'd like to do here today in this webinar is to examine some changes or additions to this standard. The first thing we'd like to look at is the Article 100 section, which is definitions. We then want to look at a new addition to the standard, which is in the back of the book, which is Informative Annex S. We will then look at a slight change to electric shock boundaries and how they apply to infrared electrical thermographers. And then finally, we want to just review a reorganized section of the standard 110.4 on electrical safe work practice training programs. So let's start in Chapter 1, Article 100, Definitions. What NFPA did this year in 2024 is consolidated all their divisions across all chapters into Article 100. There are new definitions that we will also look at, but I think it's important to note that we now have just one chapter that contains all the definitions of either concept or terms. There are 3 areas of interest that we have. There are some additions in the general safety definitions that we would like to discuss. There is the addition of many terms in what we'll say battery systems or batteries. And then finally, there are a few definitions regarding capacitors or energy storage type systems. So if you notice under general safety, we have a list in front of you: boundary, hearing protection; boundary, lung protection; hazard, arc blast; competent person; and protector. Now the first 2, boundaries for hearing and lung protection, are pretty interesting because they go along with the third one, hazard, arc blast. This is significant because in addition to our concerns of electric shock and electric arc flash, the standard is starting to develop more information on this third hazard that comes from an arc flash incident, which is a pressure wave. The last one, protector, is significant because it's taking the place of the word glove or leather glove. This is the exterior protector that would go over insulated rubber gloves. Now we'll go to the second one, which is battery or battery systems. You'll notice authorized personnel, battery, battery effect, battery room, cell, cell valve regulated, cell vented, electrolyte, and then finally pilot cell. These are all terms that will be found in Chapter 3 of the standard, but I believe one of the reasons they've moved these over into Article 100 is we're going to be seeing in the years to come a growth in battery systems being installed, particularly in the area of renewable energy. There is a fairly large push in the industry for solar and wind systems to develop storage applications, and that would be either batteries or capacitive type devices. And so we're going to see the standard, and we see it here in this 2024 edition. They're going to start developing electrical safe work practices. And the first thing that they're doing is working with the definitions. And then finally, capacitors. And again, this goes with the concept of energy storage. So you'll see dielectric absorption, discharge time, and charge transfer. All three of these really pertain to making sure that these are completely de-energized when this type of storage system has been removed for some type of de-energized electrical maintenance. So you'll notice here, what's the big deal? Well, it's great to have all these terms and concepts defined in one place. I've really already mentioned the other two. The standard is expanding our concepts of electrical safe work conditions to include not only electric shock and arc flash, but also the hazards that come from arc blast, a pressure wave. If you look up the definitions of these, hearing damage comes, as well as lung damage, at a certain amount of pressure per square inch that will affect the ears or the lungs. I believe we're going to see more of this developed in the coming editions. Also, the batteries and capacitive storage definitions. There's going to be a lot of work to be done to talk about electrical work safety when we talk about these battery or capacitive energy storage systems that are going to be installed at, say, solar panel arrays or wind farms. Let's move on and discuss briefly this new addition to the standard, Informative Annex S, or we could just say Annex S. This is found in the back of the book. It's a part of the new release, and it's very important because it discusses the concept of the condition of maintenance. Now, you'll notice in any of the annexes, and the annexes begin with the letter A, and this is the newest, S, and so there's quite a few of these annexes that are found in the back of the book. They are highly recommended, for they are informative text that gives information regarding other work that's done in chapters of the 2024 standard. But notice, there's no shall. Because it's an annex, and so there's no mandatory requirement to do what is said in this particular annex. So what does it address? Well, the first thing is the importance of determining the condition of maintenance. And you'll notice in parentheses, is the electrical equipment in good maintenance condition or poor maintenance condition? This annex talks about how to determine the condition of maintenance. In fact, infrared thermography is the first testing technology that the annex mentions. You'll notice some others like voltage and current testing, ultrasound, visual testing, and there are others. It reiterates the place of electrical safe work practices because in many cases, the work being performed to determine the condition of maintenance, infrared, voltage, current testing, ultrasound, still requires electrical safe work procedures, requires qualified personnel, requires PPE. And so they emphasize that in the annex. Another interesting aspect of the annex is that they make it almost imperative that records be kept regarding this condition of maintenance. I think this is a very interesting aspect. Not only are we going to check to determine the condition of maintenance, but we're going to keep records of it, which implies that this condition of maintenance assessment is ongoing month to month, year to year. And then finally, the annex points the reader for a more detailed discussion of how to properly determine the condition of maintenance. Look at NFPA 70B as in Bravo. 70B is the standard for electrical maintenance. And so it ties the importance of not only safety to thinking about electrical maintenance. Again, so what's the big deal? Annex S is emphasizing the relationship between the likelihood of an electrical hazard, electric shock, electric arc flash, electric arc blast, and how it's related to the condition of maintenance. In fact, if you go back in this standard to section 90 at the very beginning of the book, one of the comments that is made in that section is that if a system is properly installed and properly maintained, the likelihood of an electrical hazard or an electrical arc flash or electrical shock or arc blast is very limited or small. Secondly, it's important just to understand that if we're trying to limit or to reduce the possibility of a hazard, in this annex does speak to that. Okay, let's move on to the next change or tweak, if I may call it, that has been done in the 2024 edition, and that is regarding electric shock boundaries and performing infrared thermography. So the 70E 2024 standard has refined the application of infrared thermography to these shock boundaries. The first thing it does is it reminds us that an infrared thermographer can perform thermography within the arc flash boundary or the limited approach boundary. So let's be reminded that the arc flash boundary is a boundary that is calculated from available fault current and the fault clearing time, and that the limited approach boundary is a distance based on what phase to phase or line to line voltage that you're going to be exposed to. Now notice you can work within the arc flash boundary as a thermographer or within the limited approach boundary as a thermographer as long as you're wearing the proper PPE. You can work within the arc flash boundary and limited approach boundary as long as there are electrical safe work procedures and they are being followed. Here's the refinement. The infrared thermographer may not penetrate the restricted approach boundary, that's a shock boundary, while performing infrared thermography. So what's the big deal? Well, notice not all electrical thermographers are qualified per NFPA. Now remember, the definition of a qualified person is a combination of looking at the National Electric Code, which is NFPA 70, but also defined within NFPA 70B, the Electrical Maintenance Guideline and Standard, and then also here in NFPA 70E. So it's important to remember that if an electrical thermographer, or maybe we should say a thermographer who is performing electrical infrared, if he's not qualified according to the standards, there's a limitation to how close he is permitted to get to the electrical equipment. And notice, a qualified person, trained and knowledgeable not only in the construction or installation, but also in the operation of that electrical equipment, but also in the specific work method. Trained also to identify and avoid electrical hazards. All right, then finally, let's look at the last one. There's really no significant changes in the 110.4 training program section of NFPA 70E. It has been reorganized. But we thought we would close with just reminding our listeners about what NFPA 70E has to say about safety training. So again, this section has been restructured. There's no significant changes or additions, but again, we would like to close out the webinar reminding our listeners of these requirements. Remember, only qualified personnel may work on open, energized, exposed electrical equipment. By the way, that's what electrical thermography is doing, because dead fronts or covers or doors have to be opened or removed to do infrared thermography properly. Remember that training is to help the qualified person to be able to determine what's energized inside an enclosure and what is not. A qualified person is to be able to know and identify the nominal voltage that is within that unit, 50 volts and up, and also what are the approach distances for safety for both electric shock and electric arc flash. Qualified personnel are supposed to be able to do job safety planning. We've mentioned this a little bit already, but to identify all of the hazards, shock, flash, and blast, to assess the risks, and then finally, how do they properly mitigate the risks? So we want to remember that when we're performing infrared thermography, the required method of mitigation is the proper selection, the proper application, the proper wearing of personal protection equipment. Remember that qualified personnel too must be trained on all test equipment. They have to know how to also test for the absence of voltage. They need to know how their test equipment works and to be able to interpret the data that particular piece of test equipment provides. And then finally, they also need to know what are the limitations of each piece of test equipment that they operate when electrical equipment is open, energized, and exposed. Finally, there is a requirement at least every 3 years. Qualified personnel need to be trained or retrained. But also, there are some other reasons, like for instance, if an employer finds that employees are not complying with the Safe Work program for energized electrical work, then they're required to retrain those personnel that are not adhering to the guidelines. If any new technology, any new equipment, or any new procedures are introduced, then training is required. If an employee's job duties change in terms of what they're being asked to do, particularly if there is more exposure to open energized electrical equipment, then training needs to be performed in that case. And then finally, remember that employers are responsible not only for the training, the retraining, but they're also required to review annually the electrical safe work program. We want to thank you for joining us at the Infrared Training Center. This concludes our brief look at the new NFPA 70E 2024 standard. Again, thank you for joining us. If you have any questions regarding this particular webinar, please contact us. And then finally, if you have any questions or interest in the thermography training that the Infrared Training Center provides, please contact us. Thank you again.